Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Azim. My measure number is AD170018. The title of my project is Finite Element Analysis on Sound Pressure and Pressure Drop on a Diesel Generator Sets. As per the Chapter 1 introduction, consists of background of study, problem statement, objective of study, and scope of study. For the background study, the first one is usage of diesel generator set is crucial for industry. It acts as a backup power supply if there are any power outage. The second one is the noise problem caused by the widespread use of diesel generator is becoming a greater problem. Studies being conducted to evaluate the sound pressure level and pressure drop by diesel generator sets. The studies of duct silencer of the diesel generator sets related to sound pressure level and pressure drop produced. For the problem statement, the emission of noise into the atmosphere and does not satisfy environmental department's requirement. The second one is it may contribute to risk of loss of hearing due to noise emitted. Third one, in fact, 1.1 billion young people aged between 12 to 35 years are at risk of hearing loss due to exposure to noise in recreational settings. The fourth one is the acoustic action of the diesel generator in this situation for it to satisfy the environmental department requirement. As for the objective, consists of two, which is to conduct a finite element analysis of sound pressure and pressure drop of the duct silencer diesel generators. Second one is to compare the data obtained from finite element analysis by using analysis with theoretical results. For the scope of study, the first one is the simulation will be conducted using a model of duct silencer used at diesel generator set that usually located at class highway. The duct silencer geometric model is constructed and designed by using SolidWorks 2018. And the third one is the model instant transfer to the SC software for further detailed analysis. Chapter 2, the literature review. Diesel generator sets is a type of generator used to act as a backup power source or even main source where the premises located outside the power grid. It relies on the principle founded by Michael Faraday, which is electromagnetic induction. In relation to their function, diesel generators are made up of a generator which with the help of alternator comes into the action through combustion in the engine. Gensets can be classified into two cycles, which is the two-stroke and four-stroke. As for the duct silencer, it is usually used to reduce noise from engine power and exhaust discharge. It provides two types of work, which are providing air into enclosure and prevent unwanted noise. Splitter silencers are extensively used in ventilation, heating, and air conditioning HVAC system, as well as on gas turbine as inlet or outlet silencer. Another application is for large engine to reduce noise from the cooling fan inlet. As from the figure, the structure of a parallel splitter silencer consists of several splitters where the splitter contains a porous medium such as rock wool, glass wool, in order to prevent in order to reduce noise. Noise is intended to be an unnecessary or unpleasant sensation that could cause discomfort or hearing loss. As from the past research, a study on the effect of noise on industrial workers in Malaysia, the findings are every signal that is distracting or with a sound level greater than 75 decibel can be visible as noise. The threshold for noise annoyance varies. As for the noise effect on generator sets at construction sites, at the construction sites, electrical need to be supplied, and this is where diesel generator is used. And eventually, the generator produces loud noise. As for the sound pressure level, sound pressure or acoustic pressure is defined as special pressure difference from the ambient air pressure caused by the sound wave. It can be measured by using microphone or with a hydrophone when underwater. Investigation of the sound pressure level (SPL) of earphones during music listening with the use of physical ear canal model. From the figure, it shows the histogram of the average sound pressure level. The average sound pressure level ranges from about 65 decibel up to 105 decibel. The most frequent sound pressure level of the sample set is estimated to be around 80 to 85 decibel, where the range of the HPL is comparable to busy street. Finite element method is a numerical technique of solving problems that is described in partial differential equation. It also frequently used technique for obtaining approximate solution regarding engineering solution. Finite element method and overview. A uniform from the figure, it shows the uniform finite different mesh reasonably converted blade, but the boundary must be approximated by a series of horizontal and vertical line or stair steps. On the other hand, the finite element model is the simplest two-dimensional element. The triangle gives a better approximation of the region. As for the ANSYS Mechanical, is an integrated platform that uses finite element analysis for structural analysis. From the past research, experimental investigation on noise reduction of centrifugal blower with rectangular splitter silencer. In 2019, Anugrah and her colleagues did an experimental investigation on noise reduction of centrifugal blower with rectangular splitter silencer. They stated that with the help of ANSYS software, they are able to validate the noise level for silencer with open area of 40%, the use of rock wool, acid porous medium, and 900 mm for each length. Chapter 3 Research Methodology consists of flowchart, design, CFD analysis, and harmonic response analysis. Okay, so this is the flowchart for project that we conducted for my final year. Uh, this is the design of duct silencer. Consists of two design, which is for the consists of two model, which is for the discharge silencer and intake silencer. The length, width, and height for the discharge silencer is 900 meter times 100 millimeter times 100 millimeter. So it is in form of cube. And as for the intake silencer, the length is 900 millimeter, the height is 900 millimeter, and the width for the intake silencer is 1000 millimeter. So it is in form of cuboid. CFD analysis. This is the machine for duct silencer. As from the figure, it shows the fluid domain for the model, which is for the intake silencer and discharge silencer. As you can see, there is a kind of a block at the entrance and the exit of the silencer. It is caused to portray the connection between the silencer with the distributor sets. It connect with a canvas-like channel to prevent from distributor sets having a excessive vibration due to the engine from the genset. And the table shows the node values, element values, clearance, and orthogonal quality for the discharge silencer and intake silencer. This is the process solver for the CFD analysis for the fluent. The table shows the setting that need to be the settings needed for the simulation to perform the simulation, and the figure shows the user interface in the setup. Harmonic response analysis. This is the machine for the discharge silencer and intake silencer. It consists of two things, which is the rock wool acid porous medium and the air acid for the frequency to interact with. Process solver. The figure shows the user interface tab in the setup, and the table shows the settings needed to perform the harmonic responses analysis. Chapter 4 Pressure drop across duct sensor and some pressure level across duct sensor. Pressure drop across duct sensor, pressure drop contour for intake sensor and discharge sensor with the phase velocity of 2.47 meter per second and 1.94 meter per second respectively. From the figure contour, the upper part of the contour shows the inlet of the silencer, while the lower part of the contour shows the outlet of the silencer. In general, as you can see, uh, the inlet of the sensor has higher pressure compared with the outlet of the sensor. Hence, we can state that in general there is pressure difference between the inlet of the sensor and outlet, so there might be a pressure drop across the sensor. The graph shows the pressure drop versus z-axis for discharge silencer and intake silencer. The graph, the data had been exported from ANSYS, and I have collect 30 data from 30 location along the z-axis of the model, from the inlet of the model to the outlet of the model. So from the data, we can plot a graph for discharge silencer and intake silencer. So the initial point of the graph is at the inlet of the silencer, where the final point at the graph is at the outlet of the silencer. As is for sound pressure level and across the sensor, the contour of sound pressure level across the sensor from inlet to outlet. In general, the reduction of sound pressure level is happening as it goes through the silencer. Okay, comparison between simulation and theoretical result. For the pressure drop, the value obtained from theoretical for intake and discharge silencer is different, mainly because of the dimension and the difference in number of slither. Hence, with the different number of slither contribute to different number of pathway, and this might contribute to the pressure difference. When compared between theoretical and simulation, the value is not significantly different. As for the sound pressure level, the value obtained from simulation is still in range of tolerance and not significantly different with the theoretical. Value for simulation might be differ because of solver input or geometry. This is because in geometry, the placement of rock wool during assembly in SolidWorks is in the center of splitter and did not fill the entire space of the splitter. Hence, there might be a presence of air spaces between the splitter case and the rock wool that might interrupt the simulation process in ANSYS. Chapter 5, Conclusion and Recommendation. For the conclusion, ANSYS is able to simulate the sound pressure level and pressure drop. The medium used was air, is able to simulate both sound pressure level and pressure drop. For pressure drop, evident from results described, each design is able to keep up with the system, where its allowable limit of the pressure drop is 100 Pascal. As for the sound pressure level, the sound pressure control, the contour has tremendously influenced by the presence of splitter and rock wool. As for the recommendation, it's better to propose a better design and perform analysis, a repeated analysis and repeated design to obtain a good design for the genset. Second one is to simulate the silencer with several types of parameters, such as different sets of frequency, different types of porous medium, and the third one is high spec device or computer needed to simulate the ANSYS. And the final one is simulate other component genset such as the mufflers and so on. Okay, thank you. That's all for me.